Sì. Sta provando a fare qualsiasi cosa. Assolutamente sì. No, dice aziendale, quindi. Ma chi fai?
No, dice prima due parole.
Buonasera a tutti e grazie intanto per essere qui, è un piacere poter riospitare per la seconda volta la vostra community. Io sono Daniele Scotti e mi occupo di ricerca e selezione. Noi qua, questi sono i nostri uffici di WeHunt e W Executive. Sono due società gemelle che si occupano su vari livelli, appunto il mondo executive per profili C-level, mentre WeHunt va a coprire tutto quello che è il mercato intermedio. Siamo operativi su tutti i settori che un'azienda può richiedere. Io in particolare ovviamente mi occupo di ricerca per figure IT e quindi il motivo di questa partnership, perché ci piace essere un punto di riferimento per i nostri candidati, per le nostre community di riferimento, aprire i nostri uffici e non renderli solo dei luoghi di lavoro ma un po' dei punti di incontro. Quindi questo è un po' quello che facciamo. Siamo operativi su tutto il livello nazionale e se qualcuno poi avesse piacere in un confronto, sta valutando il mercato, state allargando i vostri team, ben volentieri alla fine di questo incontro sono a disposizione per poter essere utile. Adesso non vi ruberò altro tempo, lascio la parola ad Alberto e vi auguro una buona serata.
Io la lascio a mano. Sì.
Hello everyone, and welcome to a new Data Science Milan event. First of all, I would like to ask you if there is someone who's already know Data Science Milan or has already joined our events, or if it's the first time. So please raise your hands if you don't know Data Science Milan. Okay, more or less we are the half of the people.
Very few
so,
ones, actually.
sorry?
Very few
Very,
ones,
yeah,
wow.
less than the half.
So loyal people.
So just a few information about us. So we are an independent community. Data Science Milan was born in 2016. Yeah, thanks Alberto. And we mainly organize events related to data science, machine learning, everything related to artificial intelligence. And we usually organize a meeting once time every 2 months. We have maybe that's it. Thank you. This is our staff. I'm Manuel. Here you can find also Paolo, Massimiliano, and Leonardo. Andrea today, unfortunately, it's not here. And yeah, you can follow us, of course, on social. So if you missed the previous events, you can find on our YouTube channel. If you don't follow our YouTube channel yet, you can, of course, check the QR code here. And yeah, you can also follow us if you want in LinkedIn and Meetup and Eventbrite as well. We have a brand new website, so if you want, you can check datasciencemilan.com. If you have
made with
OpenClaw, and so if you have any question, if you want to propose yourself as a speaker or anything, if you want to join our staff, you can contact us. You can fill a form, or maybe you can reach us here. And yeah, without just spending a few words more about the job posting on our community. There is an opportunity in Atlanta. They are looking for an AI engineer. If you maybe if you are interested, you can refer to Paolo Testa that is here, and also Wiant is looking for some figures, senior data scientist, AI machine learning engineer, so on and so forth. And for these positions, you can refer to Daniele, that is close here. And what else? After the meeting, there will be an aperitivo, because I forgot that this was one of the most important part of the event after the speech of Alberto, of course. So you can grab a beer and you can eat something, and of course we can do some conversation. So already told it. So and I don't want to spend to waste more time. I leave the word to Alberto. So first of all, a big applause to Alberto. Thanks. And a few more words. Alberto is my boss, first of all. He's head of data science and advanced analytics in Nexi, at Nexi. Probably the most of you will already know him because, I mean, it's very well known in the Italian panorama. Yeah, why not? Apparently, yes. And probably, yes. And yeah, he's a Kaggle Grandmaster. He wrote several books. So this is these are some of the reasons why you should probably know him. So Alberto, the stage is yours.
Thank you so much, Manuel, for the introduction, and thank you to the Data Science community, the Data Science Milan, for having me here today. It's really a pleasure for me. I'm a guy that often takes part in meetups as an organizer, as a participant, as a speaker. I just love the vibe of these kind of events. Today, I will try and answer this question. Can your laptop run local AI? So this topic will be around running AI independently from big tech providers like Anthropic, like OpenAI, like others, and understanding what kind of performance are you expected to achieve on your machine. And it actually started with a personal curiosity of mine, as many side projects, so I was curious. It started with a nighttime script, so working a bit, okay. Now it's working. Working a bit overnight to try and solve this curiosity. But then I realized it was interesting, or at least I thought so, and I decided to scale to like a broader project. So it's an open source project. You can clone it however you like. Very, very quickly, I don't know if the speaker is working. Yes. Okay. No.
Yeah, we can.
We are also without.
Oh. Like
okay. Let's see. Anyway, that's fine. Okay. I'm a guy passionate about data and AI, basically, and I can wear multiple hats. So you know me for one, two, or all the three of them. So I'm here now basically as a nerd. So as a guy that is passionate about this kind of stuff. Otherwise, I would not be here after work. I spent a lot of time on Kaggle. I would say my specialty is probably on the algorithmic part of machine learning. So writing algorithms that actually work. So I spent a ton of time on Kaggle, became the first Italian Grandmaster in 2018, and now we are two after 8 years. So it's not a big group. During the day, I lead 4 teams at Nexi. So data science and advanced analytics made of 4 teams, roughly 30 people in Italy, mostly in Italy, but also in Denmark and Germany. So I'm, let's say, a lead of lead, as Pat Kua says. I don't know if you're familiar with this, in my opinion, iconic article, iconic taxonomy of engineering managers. It's basically tries to classify what it means to lead technical teams. It's very interesting as an article. I'm in his taxonomy, I'm a lead of lead, so I lead other technical leaders. So writing code is not my daily job. I don't write much code myself most of the time, but I don't want to get too rusty. So for me, this was an opportunity to take some rust off. I'm also a bit of an educator, so I wrote a couple of books. I publish articles on all about data and some other stuff. If you're interested on this, you can just check my albedan.github.io, my page on GitHub. Just a bit of a marcord, I was already a speaker here 8 years ago, so this is like, I don't know, some of you was already in Data Science Milan. Raise your hands. Yeah. Okay, 4 or 5 people, so okay. So I'm sort of a veteran here. Let's move forward. Let's start with the real stuff. This is a bit the agenda for today. I will start on focusing why I thought it was interesting to build an AI machine learning benchmark, because there are plenty of benchmarks out there, but in my opinion they do not cover all the questions that you might have. So I will start really with the reason why I started all of this. I will speak about the journey, building the solution, because as I said, it started with a personal interest, so I had no idea of opening this to the public or to anyone else. Then I started sharing this project with Claudio, with Manuel, with some of my friends and other guys passionate about it. At the end of the day, I actually built an end-to-end solution that is now live with hundreds of results, and I will encourage you also to contribute to this. Obviously, we'll talk a bit about the results as well. So, can your laptop run AI? What kind of performance are we expected to achieve? Because I don't know about you, but I'm very passionate about trying to run my own stuff, like using some local AI models, but I become tired and bored if it works at 1 token per second. So if I see syllable by syllable, token by token appearing on the screen, after 10 seconds I'm bored. So I will show you some interesting results. And I will talk to you a little bit about the making of. So how I built this, because I'm a computer engineer by studies, but I graduated in 2007, so centuries ago, more or less. And I've never been a pure developer in my career. So I've always been very close to the data, also close to the business, a bit halfway, but I'm not a senior software engineer or anything like that. So we'll talk a little bit about the making of. Let me start with a curiosity. How many of you actually tried to install like Oyama or VLLM or models, like frameworks like this? I would say like a bit less than half of the people in the audience. I think it will be very interesting for you, but also for the remaining part of the population, because I will talk to you a little bit about what it takes. So, it always starts with a personal need. I think now installing Oyama or VLLM on your PC is like, as it was 20 years ago installing Linux on your PC instead of Windows. So we are trying to be independent from ChatGPT, from Gemini, from the rest. And obviously we have to find some open source solution, some frameworks like Oyama in my case. VLLM is a very nice project as well. So this was really the situation that I found where I see myself in. And then I had a very practical topic. This summer, before going on vacation at the seaside, I was working at my local desktop at home. It was like a 10 years old platform. So it's an i5 4th generation. Now we reached past the 15th generation, so it's like 10 years old. And the GTX NVIDIA card that I bought, I think, in 2018, stuff like that. So it's a bit of an old GPU. And I was looking at the offers on Prime Day at Amazon, and I looked at this Blackwell GPU just introduced by this guy, Jensen Huang, more or less 1 year ago, a little less than 1 year ago, and it was tempting. So I was like, okay, it's interesting. I can spend these 500 euros. This is a consumer GPU, by the way. It's meant for video gamers. This is the typical scenario. But I was tempted, and I was like, okay, let's look at some data. Is it worth upgrading my PC for this? And I had a look around looking for benchmarks. What kind of benchmarks can I find? This is actually much more recent screenshot. I took it just a couple of days ago. But to give you an idea, when you look for benchmarks on LLM, on on large language models that are open weight, okay, so that are easy to deploy on your machine, you find a ton of benchmarks. These are the benchmarks that you can find, for instance, if you look for Qwen 3.5 models on a GIMP face. You go there, you look at the benchmarks, and you see 37 accuracy benchmarks. Okay. It was not like that 2 years ago. There are plenty of benchmarks on a lot of stuff, on knowledge, on coding, on agentic skills. You see the comparison, but they are all accuracy benchmarks. So they tell you what kind of performance when it comes to having right answers. So can it help me in writing code the best way? This is Qwen 3.5, you can find GPTs and other. So the list is growing every day. Then I look for benchmarks for speed. Okay, and this is what I found, nothing. I don't know if you ever try to answer this question, but there is not a standard benchmark for speed on local LLMs. Hopefully you identify the movie that this clip is taken from. You can find some random data. Maybe someone on Reddit posted a benchmark, posted some data on his local PC, but it's not reproducible. So it's difficult to understand what you can achieve on your GPU with a given LLM, what kind of speed, token per second, to put it bluntly. I was in the buying phase. I had this dilemma, is it worth buying or not? I ended up looking at video games benchmarks, and I say, okay, more or less it's a reasonable proxy for taking my choice. And at the end I decided to go for it. So I actually bought the GPU. But before disassembling my old PC and assembling the new one, I was like, okay, let's build something to measure if it was a good purchase or not. And it started this way. Actually, this was the first reason of the project. There is also a side quest, let's say, a side goal, a personal goal. The fact is that when you are in a management role, inevitably when you start being a manager, let's say, you lose a bit your technical skills, your technical credibility, because you spend less time on that, working on coding and stuff like that. Hopefully you grow in a leadership role, hopefully. But I think side projects help in not becoming too much rusty, so not losing contact with the reality. So for me, it was definitely something to do. It was I had all the reasons to try them. The interesting thing, and I will talk about it later, is that AI assistance for me was fundamental in developing this project, because when you are actually building a project, sooner or later you will get stuck with some errors, especially if you're not a coder full time, and if you are just doing a side project at night. So you typically get bored or tired or stuck, and before AI assistance, you usually would just let the project die and never see the end, the success. It was very interesting for me to use this kind of tools. So let's go a bit to the solution. I will talk about the journey that I took. I will organize it in 4 steps because it's actually how it worked. First of all, I was like, okay, let's try to have a bit of a product vision. What do I want to build? I want to build a benchmark that has these 6 characteristics. The first one is I want a reproducible suite of benchmarks. So even if I didn't think about opening it to the public, I just wanted to be able to reproduce it on multiple machines, on multiple platforms. So it was like, it's the standard thing for a benchmark. Then I wanted it to be configurable, because there are tons of large language models. I like many really a lot, like Qwen from Alibaba is a very nice set of large language models, but you can try Mistral models as well. You can try DeepSeek. You can try a ton of others. So I want it to be configurable to select different models, very, very flexible. Then, I work in machine learning as well, not generative AI. We spend a lot of time in my teams also working on machine learning, and I was like, okay, let's consider also machine learning, because the speed in machine learning is also relevant. So I wanted to build a benchmark that included both topics, so generative AI and machine learning, traditional machine learning, let's say. 4th topic, no budget. This is something that I put as a constraint to myself. Use only open source tools or free tiers, we will see it afterwards, so spend €0. And in the development and in the solution that is running nowadays, all the day, every day, it runs with €0, so it's something nice. Obviously open source, the platform, you will see it later, you can clone the repository on GitHub and contribute yourself, it's open source. And obviously I wanted to have fun, because you know, it's a side project, done at night, you need to have fun, otherwise you just get tired and leave it halfway. So level 1 is very simple actually. What I obviously worked in Python, I didn't say it, but Python was my go-to language. I used the UV, that is, let's say, package manager, everyone loves UV. Despite being recently bought by OpenAI, as some of you may know. But it replaced like poetry or standard pip for many people and for me as well. So I decided to use this. I chose XGBoost as a traditional machine learning library. And it's good because it works both in CPU and GPU mode. Okay, so you can accelerate those in GPU mode. And Oyama is basically a wrapper around the Yama CPP. And it's basically a way to run local AI on your PC, local generative AI. You can run Qwen 3.5, you can run whatever other model you like. Obviously, for me, everything was to be orchestrated by a single runner that reads a single YAML file. So everything is configurable in a YAML file. You can customize many things. Let's go through some of the details. I talked to you about XGBoost. I use the standard dataset, the X dataset. Some of you are familiar with it. It's a pretty large dataset. It's 11 million rows. Actually, in the benchmark, by default, it's subsampled 100K, 1 million, and full dataset to try different sizes. The KPI here is training time. So the faster, the lower, the better. The faster, the better. Obviously, the YAML configures multiple runs and stuff like that. On Oyama, you know, the interesting thing is that when you define a standard prompt, obviously you can get different results, different answers. But the speed in token per second is a constant and is related to the model and your environment, your GPU or your CPU. So even if the answer can be longer, shorter, whatever, the speed is a constant. So I put a standard prompt in the YAML file, and this is what is run. I try obviously models that can fit in a consumer GPU, so from 3 billions to 14 billions, but you can try also larger models. I also tried the larger ones. They are taken from the Oyama model library. It's something that you're familiar with. I tried also Gemma, Phi from Microsoft, Phi from Microsoft, and others. Again, it can run both in CPU and GPU mode. If you run Oyama by default, it runs with GPU, but you can force from Python to use the CPU only. Altair is my plotting library of choice, but you can choose any different one. So it's pretty simple. The architecture as it is very, very straightforward. You have a YAML configuration file, a runner that orchestrates 2 benchmarks. I could add a third one, whatever. Oyama for LLMs and XGBoost for traditional ML, and it produces some results, some CSV results. Here started the problems, because you know every project has some problems. The first one came from working with one of you, Claudio, that told me, okay, I tried to run the benchmark, but I have a corrupted download. Okay, long story short, X on UCI repository, super low, it's a CSV, so big and not compressed. So I repackaged, now it's available on Hugging Face. You can repackage this kind of stuff without incurring in any license problem, by the way. So the CSV size was 2.6 gigabytes, now it's 0.6 as a Parquet file, and it's on Hugging Face, so it's 10 times faster as bandwidth. So now it's a breeze to download the dataset, it's very, very quick. I got some obscure errors on some old machines of mine, because I tried this benchmark on older machines. I even used machines from the early 2000s. It doesn't run, but it's not a problem. You get some error code like this, because the CPU lacks physically the SSE functions, hardware functions. I accepted this. I tried to fix it, but it was not something worth spending much time on. And I started to realize I did a good purchase, by the way. But yeah, it was really simple. It's basically very simple Python, no complexity whatsoever. Then I realized it was quite a bit interesting, and I decided to scale a little bit to open it to the community, let's say. So I was like, okay, how can I enable someone sharing the results with me? Okay, I wanted to give it to my friends, like some of you, and avoid them sending me an email with the results. Okay, it's a bit old school. So I decided to code something else. By default now the CSV get encrypted just for fun. There's nothing, to be honest, sensitive in this data, but it's encrypted with a typical private-public scheme, asymmetric cryptography. And I looked for some open, unauthenticated storage. So I wanted to have a place where people could upload files, again with €0 budget. Remember the constraint at the beginning. And at the end of the day, I found this file bin. File bin is, I wouldn't say shady, but it's not really transparent as many of this kind of solutions. It's unauthenticated storage, so everyone can upload anything without being traced. You can imagine it's not used for the noble purposes usually, okay? But I use it for a noble purpose, okay? Obviously, there is an opt-out available. So if you want to run the benchmark without uploading the result, without sharing to the community, you can opt out, but you are selfish if you do this. Then I was like, okay, but I need to understand when someone has uploaded something. So I decided to build a Telegram bot. So I received the notifications on Telegram. Some guy uploaded the results from his benchmark. Okay, again, some challenges. File bin is very obscure. The APIs are very obscure as well. Lot of problems making it work, but in the end it works. For instance, it deletes the bins after 7 days of no upload. So while I was developing, and I hadn't even shared with some of my friends, yeah, at some moment I found some random mistakes, some random errors, just because the bin gets deleted. The bin is just a string, alphanumeric string, is unique when you create it, and it stays over and over if you upload at least a file every 7 days. So I built like a keep alive to avoid the bin getting deleted if no results are found. So a lot of trial and error on this. This is what file bin looks like, by the way. This is the file bin that I actually use. You can find many keep alives for the days where no one uploaded anything. But then you can find Oyama results, XGBoost results. They're all encrypted, as you can see. I've got the private key, obviously. Only I can decrypt this kind of data. It's free, it's authenticated. I avoid in this way any possible problems. I could have set up like an S3 bucket, stuff like that, but I would have to pay some cents, and it would not be a big problem. But still you have to secure stuff to avoid being exploited in any way. So in this way, for me, it was much easier. The bot, the Telegram bot, how many of you tried to set up a Telegram bot? Okay, a few of you. Very easy to set up. It's a breeze. So whenever I receive new files, you get I get the notification. New file arrived, and it works. So the architecture is starting to look a little bit more articulated. Okay, you get the first part of the solution. Okay, the results get encrypted. With my let's say a public key. So I have the private key to decrypt it. They get uploaded to file bin. Okay, so this is a file bin, and then I wanted to look in this file bin to see if new data was available. So I had to find something to look for data in the file bin, and then send notifications to my Telegram bot, but also write a keep alive if no file was found, to avoid the bin being distracted, being deleted. And so it started looking a little bit better, but I had a question. How do I orchestrate all of this? I want to orchestrate some of the activities. And so, with a bit of success comes a bit of ambition of trying to make something reasonable. I say level 3 going pro. Okay, it's not really pro. As you can see, there is a bit of a hacking mentality, making stuff work in this project. Going pro and serverless, by the way. I found out about GitHub Actions. So keep in mind, I'm not a cloud engineer, I'm not a data engineer, not a machine learning engineer, I'm a manager of managers. I found out about GitHub Actions, and I was deeply impressed, because they can be used to orchestrate, to do some computation. You can do a lot, again, by configuring a simple YAML file. Simple or not so simple, let's say. But then I was like, okay, I don't want to just receive a notification on Telegram and stuff like that. I was like, okay, I need a database. I want to store the results on a database. Everyone loves DuckDB, I think. I see some approval, okay, so I love DuckDB as well. I didn't know till a few months ago that they also have a hosted version that is called MotherDuck. MotherDuck has a very generous free tier. I could store millions, billions of results in the free tier. And so I decided to use the serverless version, the fully managed version, the MotherDuck. Obviously, GitHub Actions makes it able to store also the secrets, so properly store the APIs, properly stores the private keys and stuff like that. Also some constants like the file bin number, the file bin code are stored in GitHub Actions. How does a GitHub action look like? This is the actual GitHub action. It's scheduled to be run daily, okay? Then maybe I can also run it from time to time manually. There are basically, the interesting part is this section, five operations that get done. First one is monitor the bin for new data using file bin APIs, and notify, send a notification for new data available. Now it's just for curiosity, someone uploaded the result, but it's something that I do. Then there is the download of the results and the decryption using the private key that is storing the secrets. There is obviously some schema validation. Again, it's just for fun. It's to make it a little bit more robust. Even if I do not expect any kind of attacks on this. But just in case, I validate the schema of the results, OYAML results and CSV results. Then there is the insert on MotherDuck that is used with MotherDuck APIs. And by the way, I keep a list of seen and unseen files because, again, file bin APIs are not the best to work with. I have to be a little bit artisanal, so keeping a list of seen files and so on and so forth. This is all orchestrated in a YAML file in GitHub Actions, run in 30 seconds. I schedule it to run every day in the morning. And again, there is a generous free tier also in GitHub Actions if you want to enjoy it. Okay, the architecture is growing a little bit again. You saw the part in green, that is the repository that you can clone. I will show it later. There is the file bin. Obviously, the orchestration takes place with GitHub Actions. When there are no new files, obviously there is a keep alive that keeps the file bin alive. When there are new files, notification, download decrypt, and insert in a staging area in MotherDuck, because I want to do serious stuff, so staging area. Doesn't go straight in production. Last step, results democratization. I was like, okay, I'm starting to collect some results. First of all, I want to ensure the quality of the results. So this is the only step that I kept manual. So I do manual promotions from staging to production. So I have separated tables. It's, again, a bit artisanal. But I am the one that decides what to insert in the production, in the reference table, okay? Because what I saw by sharing this project is that there are some people that compulsively run the benchmark every day. I have a guy with a Xeon, maybe he's in the audience, I don't know, that runs the benchmark every other day. So I see a ton of results from Xeons. But I'm very happy about it. But I don't want to promote everything to production, otherwise I would be flooded with Xeons that are the Intel server CPUs. So manual promotion, and then a little bit of a front end, obviously, because I have everything that it's needed. I have a MotherDuck, so I built, and I will show you live, a Streamlit interface that is pretty nice, in my opinion. That also has a SQL playground, by the way, so I can write some queries also directly in the SQL playground in Streamlit. Again, €0. It's hosted by Streamlit Cloud. Streamlit Cloud, again, very generous free tier and so on and so forth. So these are some actual results. There is someone with an MSI Katana that is not a sword, but is a laptop with an NVIDIA GPU and some other guys. So this is the architecture. It's not rendered perfectly. This is designed with Mermaid. I don't know if you're familiar with Mermaid. You can code nodes, edges, and so on and so forth. You can code a graph, basically. What I added are reference tables, okay? So the views on Streamlit collect the data from reference tables, while with the SQL Playground you can query whatever data you like. You can query the official data, the production data, as well as the staging area. The only manual step is the review and promotion from let's say, staging to reference. So, what are the technologies that I used, all in all? Level 1, I started with UV, Python, Altair, that in my opinion is a nice Python library for plotting. It's not super well known, but it's pretty. OYAM and XGBoost, obviously. Then I added the raw data sharing and the notification. So I used FileBean and Telegram bot. I added GitHub Actions and MotherDuck afterwards, and finally the Streamlit front end. And it's working. It's working every day, so I'm collecting everyday results. Just yesterday, I collected results from NVIDIA DGX Spark. That's a GPU, 5,000 euros, more or less the cost of this GPU, of a guy that ran the benchmark on this. It's a GPU with 128 gigabytes of RAM, so you can do some cool stuff on that. So let's see some results. This was my original dilemma. Okay, let's start with my curiosity. This is my new GPU, this was my old one, new CPU and old one. So, this is DeepSeeker-1. It's probably the first open source, open weight reasoning model. 14 billion parameters, so it's as big as 11, 12 gigabytes, okay? So it fits in the VRAM of my new GPU, and it produces 4 tokens per second. On my old GPU, it produces 4, so it's 40 and 4 tokens per second. So big difference because it doesn't fit in 6 gigabytes of RAM, okay? On the CPU, it's obviously very, very slow, especially on the old CPU. Then there is a smaller model. I took Phi3 from Microsoft. There are better ones, to be honest. Less than 4 billion parameters, super fast on the new GPU. Still pretty fast on the old GPU as well, because it fits into the VRAM of the GPU, and slower, obviously, on the CPU. And then some data from XGBoost as well, because I think we all love XGBoost for classical machine learning. You can see the difference on a new GPU and an old CPU. It's 15 times as fast. So from 150 seconds to 10 seconds, the same task. It's faster, actually. It's pretty accelerated on GPUs as well. So again, this is some interesting data.
What's the performance of the Ryzen one?
This one?
It's impressive because it's a pair of the GPU.
It's a pair of the old GPU, but again, there are like 6-7 years of difference. So it's yes, it's interesting. It's still faster on larger data set. Let's deep dive on generative AI. I like this project because I collected a lot of results from people that have different hardware and stuff like that. So I compared on DeepSeek. I took just DeepSeek. My GPU, my CPU. This is the GPU of a colleague of mine that is a serious gamer, very serious gamer. So this is a GPU that costs more than 1,000 euros, 1,500 probably. And these are like the Apple M4 Pro, and this is like an all-in-one AMD solution, quite expensive, close to 2,000 euros. And you can see the difference. You can see why NVIDIA is the largest company in the world for capitalization. It's way faster than machines like the Apple M4 Pro or the Ryzen AI Max that are still impressive when compared to a regular CPU. So these are the kind of differences that you can expect. yeah, a lot of considerations could be done on this topic. For instance, this is a new generation CPU. This is an older one, but it's a higher tier, so it's a higher level. It's enthusiast level of the previous generation. Still quite a bit faster than my mainstream GPU.
You should add also the consumption, the power consumption, because it's really.
I should, but it's difficult to collect this kind of data. Some question.
Do you have any information regarding the quantity of RAM? Because I know that, for example, for Apple CPUs that have a mixed architecture where RAM is unified between CPU and GPU, I think that also RAM size can impact on the
yes.
benchmarks.
For these two, they have a shared memory architecture, so all the memory is used both for GPU task and CPU task. It's different from these other three.
Since your tool is able to collect the RAM information,
at the moment I do not. At the moment I do not.
Because
Yes.
I was thinking to buy, and my question is how much RAM you add, because
Let's say the rule of thumb is if the model can fit in the RAM or not, obviously. And again, another rule of thumb is that 14 billion parameters more or less are 14 gigabytes. Is actually less than that, but order of magnitude.
So, when you say M4 Pro, is it optimized for Apple Silicon or is the classical level?
Just yesterday or 2 days ago, Oyama released the 0.19 version, and it's optimized for Apple Silicon. I just read the news a couple of days ago. This is an older version. Every time I store also the version of Oyama, and I will show you something just in the next slide, I guess. No, the slide after. So this is actually a bit of the front end in Streamlit. So these are all the results on DeepSeek R1, 14 billions. Actually, nowadays there are more than that. This is not up to date, it's a few days ago. Then you can see really the differences, and you can navigate it however you like. To the question of Massimiliano, you can use this kind of tool also for different things. For instance, like version 0.10 of Oyama, they declared improved performance in Gemma 3N models by 2-3 times. Actually, I benchmarked it. I have an older benchmark with 0.96 and with 0.11 version of Oyama, and it's actually twice as fast. So you can also fact check this with a proper validation framework. I don't have an Apple device myself. I could try, or I should try to find someone that. Great. Please do. This is something actually I coded in the weekend on Saturday. Some add to add. Once you have the data, you can do plenty of stuff. The point is collecting the data. For instance, this is add to add comparing two systems. You can compare any random two systems in the database and see with the benchmark that they share what is faster, what is slower, and the same with XGBoost, and get like an idea of the winner, let's say. Okay, this is, I will go live also on this to show you something more. This is indeed, this is my new desktop, and this was my old desktop. So plus 400 plus increase, I did a good choice. I can go live. I think let's try and go live. I will show you a little bit. I don't know if the recording will work. Otherwise, the live session is only for the ones that are here physically.
It's a free
okay. Oops. This is my enterprise PC, but it works. So currently, I have like 108 results on XGBoost, 161 on Oyama, some pending results. I have to delete some of them because they are duplicated of some people that can possibly run the benchmark. Some new results have been updated just yesterday because of the NVIDIA DGX data. What can I show you? Let's go with the add-to-add, for instance. That is fine. I don't know. Let's take this PC. This is a gaming PC from a friend of mine, by the way. You can see really live the comparison. Let's see. Okay, you can see on different model which one performs the best, what kind of speed you can expect. also on XGBoost. Actually, I realized over time that working on 100K rows, no matter what PC you have, it's gonna run in a split second, so it's not really a valuable benchmark, to be honest. But on 11 million rows, it still takes a few seconds.
Sorry, can I ask you if you want
Yeah.
to just to share the whole screen in order to?
Let's do this.
Yeah.
Let's do this.
So for the people that are remote, yeah.
Okay,
Thank you.
let's interrupt the screen share and let's let me try to screen share. Where is it? Ah, yes, it's here. Okay.
Yes.
Should work.
Yes.
Is it working? Okay.
It's there is a little bit of delay, but
Okay.
I think yes.
You can see the results, for instance, on XGBoost as well. As you can see, I have a ton of results, quite a bit. You can filter them the way you prefer. You can compare, for instance, only GPU results, and you can see what kind of results to expect. I don't want to bore you with countless examples because it's free. You can navigate it yourself. I will share the links. It's also interesting, for instance, the XGBoost versus Oyama performance. So you can choose a single LLM, for instance, DeepSeek. You can choose a data set of XGBoost and see this scatter plot. Where is my machine compared to the others? And you can leverage the overlay. Right? I took the Apple M4, for instance. Okay. So this is an example of what you can get. Obviously, you can also run some queries, read-only. You cannot drop the database, hopefully. And okay, these are my results. I can sort them by. Let me write something. Let me write an order by. Okay, order by timestamp. Usually write code with two ends, not with one. Okay, this is the DGX Spark, for instance. So it's an impressive machine from NVIDIA that can run this very easily. But there are also other interesting results from countless GPUs and so on and so forth. So this is let's say, the interface that you can use. Let me navigate a little bit to the benchmark. So I do have, condividi invece questa scheda. Yes, should work. This is really the repository of this project. There are all the instructions in order to be able to run it. It's actually very easy for all of you in this room because you just need to have UV installed and follow the README that requires you just have to clone it and run it with a single command. So you should all be able to do this. It runs on Python 3.13. Obviously, if you want to use the GPU, you need to have like CUDA installed. I have no one that tried with the equivalent of AMD that I cannot remember the name of ROCm, exactly. You need Oyama running on localhost, and you need to download the models that you want to benchmark, you want to test. Obviously, you can navigate the code however you like. To give you an idea, this is the YAML that I was talking about that has all the configurations in the world. You can specify the name of machine, CPU, GPU, otherwise it takes it automatically. Customize how you run XGBoost, how you run Oyama, what kind of models to test. You just comment the rows that you're not interested in. You should all be very familiar with this. You can also run it with GPUs only, with both GPUs and CPUs, and so on and so forth. So let me jump back to the presentation and let me reshare the PPT. Okay. Okay. Let's move a little bit further, and we are close to the closing. Making of. Okay, let me go a little bit with the making of. I'm not a developer, as I said. It's not my day-to-day job. So I wanted to experiment a bit with coding tools. Actually, what worked for me is very, very basic, so don't laugh at me, but I just used VS Code and I had my ChatGPT subscription, the Pro version on a side. I used 03 and 04 because ChatGPT 5 was not released when I started working on this. Then I switched to ChatGPT 5 Pro and it was amazing for very complicated questions. And for me, it was a partner. It was like a sparring partner on the architecture, what works, what not. It was like having an assistant that is always ready to help, to understand the APIs of FileBean, to solve some weird issues. This worked for me. Obviously, if I had to start from scratch nowadays, I would do it differently. But it's, it's working, and I'm quite happy with it. The speed up, for those of you that are managers, everyone is asking, oh, is it speeding up your developments? Yes, it's speeding up plus infinite my developments, because I would have stopped. So I would not have deployed anything, released anything. So the actual value for me has been joy of developing something as a project that comes to life. And I had definitely a better understanding of a lot of technologies. So in my day-to-day job, I will never be the one that writes the YAML for GitHub Actions, but now I know a little bit what it means, and also the other technologies that I showed you before. What are the prerequisites to do this? For me, it's very important to have a tech background. So you cannot use this kind of assistance if you don't know what you're doing. So even if I'm not, I'm a bit rusty, let's say, on some technologies, but I know what I'm doing more or less, and so I can enjoy having a smart assistant. And the thing is, it's very important to have a product mindset, because what I showed you basically is a product roadmap, because the level 1 all the way to level 4, it's like a product that evolves. I add component, I add new stuff. So I designed my own product roadmap. So I was the product owner as well as the developer, as well as everything, also the commercial guy, apparently. So it's a bit of a one-man show. Is it production-grade code? No, it's not production-grade code. I don't write production-grade code also at work. It's not my job, but I can recognize production-grade code from random code. It's not that bad, to be honest, but I wouldn't consider it like reasonable for a production environment. For me, the code is acceptable for a side project. So I had fun, I learned a ton. So I'm not a Nazi of using all the best practices in coding. If it's a side project, it's fine, if it's not perfect. Obviously, it's a project that has no interactions with other complex systems, so I don't care if I create a little bit of technical debt, let's say, inside this project. It would be different in the enterprise. Again, I learned a lot. It was important to think of it a bit as a product. Whoops. So let me close with this slide. Here you can find the dashboard if you want to navigate the results, if you want to notify me some possible bugs and stuff like that. You can find the repo on GitHub. This is the repo for the benchmark, by the way, because the automation is on a different repo, obviously, and also the front end, the Streamlit front end, is on a third different repo. These two are private, while the benchmark obviously is public. In order to run it, just clone the repo, run uvrun suite.py, and do not touch anything. The result sharing is open by default, otherwise there is a simple flag you can turn on if you don't want to share the results. And if you're interested in getting in touch, again, you can find myself on LinkedIn or look at the GitHub. So that's it, guys. Questions?
How much time did you spend roughly in total?
Okay, how much time I spent? I would say most of the stuff has been done on a few nights before going on vacation, late July last year. I would say 4 or 5 nights for the core stuff. But then I keep adding small stuff, something also the last few days. So, I mean, having it run end-to-end, I would say some 20 hours. I don't know, it's very difficult to estimate for me. Maybe less than that. Any other question?
You mentioned before that you mentioned before the LLM, for example. shared to everyone. And you find other type of runtime or framework that are very good to test?
I like Toyama for its simplicity. To be honest, I didn't have the need to test new frameworks, even if I know some guys that are very supportive of VLLM. That's why I mentioned it. So I don't have direct experience in this. Personally, with Toyama, I'm quite happy. So I've been using it. Originally, for instance, it didn't have any kind of front end, so you had to use like OpenWebUI, for instance, if you want a ChatGPT-like front end. Now it comes with the basic front end itself. So yeah, I think just remember the original dilemma. So it was basically to benchmark the GPUs, so anything would do, more or less.
Because in my experience, Polama is really good because it's really smooth and fresh.
Yeah.
But Cobol, for example, Cobol AI is a better tool for speed and for concurrent
sessions.
Okay. And for EMD is Lemonade.
Okay.
Everybody are using Llama CDP, but
yes.
they are a little bit more.
Okay. I see. Interesting. Anyone else, please?
Sorry, I saw last week that Google Research published the TurboPont paper.
Yes, I saw it as well.
Do you think this world will change?
I don't have the crystal ball, so the world can change any time on anything nowadays. No, it's an interesting paper. I don't know if it will be revolutionary as it seems. Still, the good thing of having a framework, a standardized framework, is that you can test evolutions. So if I saw a simple example in testing new versions of Oyama, for instance, but keeping the same framework makes it able to benchmark it. Because from theory to practice, it doesn't always translate linearly.
You think you can upgrade data for enterprise benchmark? So you say that it's for local PC, to benchmark local PC, but is it possible you think about to upgrade this and maybe the company enterprise can benchmark the server or the people data center and so on?
I did receive some server. I don't know as Axion at home. Maybe someone, but Axion or Threadripper for AMD are server CPUs. So I suspect that someone is running on enterprise hardware. It's interesting. I don't know. It started really with a side project, so I have no plans to scale it more professionally. But it would be very interesting. For instance, I can go also live a little bit again. The results from yesterday from NVIDIA DGX are very, very interesting. Let me share them also this way. Okay. This one, Streamlit. Should be this one. Okay. For instance, let's go ahead to NVIDIA DGX. Let me find it. NVIDIA DGX is almost an enterprise level, almost. And this is my local machine. Actually, it's interesting because the only case where this NVIDIA DGX that cost $4,800 is better than my local PC that doesn't cost as much is on large LLMs. So Qwen 3.5, 35 billions do not fit in my RAM, and actually you can see the difference, the huge difference. But on smaller models, a consumer GPU is much better. And also on XGBoost, for instance, it's much better to have a consumer GPU. So yeah, again, it's very interesting for me.
One question for XGBoost. Is it parallelized, right?
Yeah, absolutely. Yes. By default, it uses all the threads that are available. Also, the GPU implementation, it runs only in CUDA. So if you have like an Apple machine, Apple Silicon, it runs only in CPU mode. But that's a limitation of the library, not of the benchmark.
Which is in Apple is a disaster.
Yeah. I guess that's the reason why it's not implemented.
Honestly, I'm not surprised about this because they of the consumption.
Yeah.
the work.
Yes, true.
Maybe off topic, but would you use for any personal or professional task one of the LLM, open source LLM you can see?
Okay, that's a good question. Because the good thing is being able to test them. One thing is benchmarking and then is running. I will tell you a very, very quick story. I keep in my bookmarks, let's say, a lead code question on SQL, hard difficulty, okay? To be honest, if you look at it, it's not super hard, but you're quite familiar with running SQL.
You're a grandmaster.
Absolutely. No, it's I tested Qwen 3.5, 35 billion parameters. That's actually 35 billion parameters and 3 billion active at inference time. And I tried GPT-5, GPT 5.4. GPT 5.4 answers perfectly in 1 second. I take the answer, I paste it on lead code, and it runs perfectly. Qwen 3.5, 35 billions on my local machine, that is the one on the right, gives me an answer after 90 minutes of thought, of thinking, and it's correct. But it takes 90 minutes of reasoning. I tested, for instance, DeepSeek R1. It takes 20 minutes to give an answer, and it gives a wrong answer. So I paste it on lead code, and it's wrong. So that's, I mean, Qwen 3.5 for me is very good. Also the smaller,
it's one of the latest ones.
One of the latest, been introduced a couple of weeks ago or 3 weeks ago. Still, it's difficult to rely on them for real stuff. That's my impression. Even if you fine tune it and so on and so forth, but it's hard.
90 minutes.
Yeah.
Are you sure that result comes from model reasoning, or just it embedded the, let's say, the lead question in the data set, so it's basically a memorized reply?
Okay, you're saying, you're questioning if it can be contaminated. I don't know.
They are public.
They are public. I don't know. That's a good point. But my general usage of local LLMs and GPT 5.4 is more or less in line. So there could be contamination indeed. I don't know about it.
What are the next features?
What are the next features?
Yeah, exactly.
Actually, the Z2 add.
What is level 5?
The Z2 add was suggested to me by a common friend of ours, by the way, by Mario, and so it's yes, I'm getting requests, and I add it by request. I should keep track, for instance, of driver versions in GPUs that I currently do not keep track of, like NVIDIA driver versions. I should store better the RAM size, definitely, and small adjustments at the moment.
Even OS version.
The OS version is yes. If you want to see, yes, yes, I can show you also later on.
Okay. And then the future could be supporting other models like text to speech or image recognition.
Yes, so could be very interesting. The other aspect was like this, so supporting new models, multimodal models could be interesting. I also thought about a GUI, a graphical user interface for the benchmark, or a text user interface, a TUI. At the moment, it's just a command, and I think the audience are nerds, so they can clone a repository and they can run a single command. But still, I tried, for instance, playing around with nice GUI. There is this amazing Python library only for the name, nice GUI, so nice guy with a graphical user interface, but I didn't finish it.
Maybe also time to first token could be a metric.
Time to first token could be interesting, yeah. The thing is that the speed is provided directly by Oyama, so it's very easy to collect this information. Still, it could be interesting.
If you have multiple submission, you do simple average, you do some cleaning of your bias.
By default, every benchmark is run 3 times, so I take the median result. You can also run it 10 times if you like. Just configure it in the YAML and I take the median result. there are people that run the benchmark multiple times. Every time you run a benchmark, there is a unique ID that gets generated, so I can sort them, and they typically promote one of the multiple runs.
Have you started playing with NPU?
With them?
NPU, Neural Processing Unit.
Nope. Could be interesting. It's not on my list, but
You can try quantum computing.
I think this is a question for starting the aperitivo, right? Okay, guys, I think we can.
If you don't have any other question, we can go to the next room. We'll go here for another video. Thank you so much. Thank you.
Ce l'abbiamo fatta. Bene.